This section is 3.1, the first section in the third unit, and the focus of this section is the relationships between lines and planes, as well as some new vocabulary, some angle pairs that are formed with parallel lines and transversals, and we'll learn what that line or word means in just a minute. Some terminology for you to write down are in the first part of these notes here, and the first word is parallel lines, which are lines that are coplanar or on the same plane and do not intersect. So for that, you might want to write these lines down in that definition box as well, these line segments. But some examples of that would be the two segments that are highlighted there, line segment AB and segment EF. Also, segment AB and segment DC are parallel. They're both in the front plane and they will not intersect. And then finally, segment BC and segment FG are also parallel lines. Another term is skew lines. These are lines that are not coplanar, so they're not in the same plane and they do not intersect. These are some examples are AB and segment FG. If you want to write those down as well, that'd be a good idea. Segment AE and segment HG, notice they're in different planes and they will not intersect. And the final term here is parallel planes, which are planes that do not exist. So these intersect. So these are planes that are on opposite faces of a figure. And one example would be plane ABC and plane EFG on the front and back of this prism. So first example has a few questions about this figure on the right, and the first question is how many planes are in the prism. This has planes on the front and back, and then also left, top, right, and bottom of the figure, so there's a total of 6 planes there. And a plane parallel to plane ABE, well, plane ABE is on top, so the parallel plane would be plane DCG. Notice the name of the plane has the word plane in it, and then 3 points are used. You can use any combination of 3 points, although you should go in order around the edge of the plane. And then a plane parallel to BCG on the right face of the figure would then be plane DAE on the left face of the figure. The next question is the intersection of plane ABC in the front and plane BFG on the right side of the figure. When two planes intersect, it always makes a line or a line segment. In this case, that's segment BC. Then the intersection of plane EHD on the left face and plane ADC on the front face is segment AD, where those two planes meet. Then the intersection of plane HDC, which is on the bottom, and plane BCG on the right side, is that segment CG. On this slide, it looks like not all my animations are working, but you can still see the answers to each question. All segments that intersect AB. So this is any segment that meets AB at some point. So segment EA, segment AD, segment BF, and segment BC, you can see all intersect that segment AB. Then any segments that are parallel to AB are ones that are in the same plane and don't intersect. So that's segment EF and segment DC. Segment HG will not intersect segment AB, but it's not in the same plane, so it is not considered parallel. Then all the segments skew to AB. That's all the rest of the segments in the picture. That's segment HG, segment EH, segment DH, segment FG, and segment CG. Some more terminology for you here. Starts with the word transversal. Now, the definition of a transversal is just a line that intersects two or more lines, and to intersect, they all have to be in the same plane. An example is here's two lines, and that red line there that crosses both of them, that intersects both lines, is the transversal. Okay, with these next vocabulary terms, these all refer to specific pairs of angles in the figure. And although I give you one example, there's one or two examples, there's often more than that. Interior and exterior angles are the first two. And to be able to use these terms, first you need to know that the interior of two lines is that part shaded in gray. It is inside the two lines. So interior angles are the four angles between the two lines. So that's 3, 4, 5, and 6. The exterior angles refer to the angles that are outside the gray area, that are not between the two lines. So that's angles 1, 2, 7, and 8. The rest of the terms are the angle pairs. So the first term is consecutive interior angles. Consecutive, really that just means that they're on the same side of the transversal. So for that, they're interior, so they have to be between the two lines. And then consecutive means that they're next to each other, or they're on the same side. So that's pairs like 4 and 5, or 3 and 6. Then consecutive exterior angles, the only difference is they're exterior. So now these are angles that are outside the two lines that are roughly parallel. And then they need to be on the same side. So these are pairs like 1 and 8 and 2 and 7. Then with these three more, you have alternate interior angles is the first one. So these are in the interior. Alternate means that they're on opposite sides of the transversal. So this is angles 4 and 6, or 3 and 5. Alternate exterior, now they're on the exterior, not between the two lines, and they're on opposite sides of the transversal. So this is like pairs like 1 and 7, as well as 2 and 8. Then finally, the last type of angle pair are called corresponding angles. If you look at the example, the first pair of corresponding angles is angles 1 and 5. Corresponding means that they're in the same zone of the intersection relative to the transversal and its line that the transversal is crossing. So angle 1 is in the top left and angle 5 is in the top left. Other corresponding angle pairs are 2 and 6, 3 and 7, and 4 and 8. So here's the second example. If you look at this figure, there's lots of possible transversals here. So line M can be a transversal if you're referring to P and Q being the two lines that it crosses. Line P could even be a transversal if you refer to the fact that it crosses lines M